Good morning, Algebra 2, maybe afternoon, and maybe even evening. My name is Mr. Wagner. I'm currently living inside a computer, and let's jump into some more polynomial action. Today, what we're going to go over, this little thing called end behavior, as it deals with the graphs of polynomial functions. And then we're going to move into adding, subtracting, and multiplying of polynomials. So we'll start right here. The end behavior of any polynomial function, this is defined by as x approaches infinity, or the extremes left and right of a graph, in which direction the polynomial ends up going. For example, all polynomials follow these directions, just the way it goes. Right? If you have a cubic function, x to the third, it grows in this manner. It starts low, goes up, up, up. Some things happen in the middle, and as you get bigger and bigger, bigger, it's just growing bigger and bigger, bigger. Right? The reason why this is so, say for example, 5x cubed minus 20x squared plus x minus 28. This is a cubic function because my degree is 3, the biggest degree. As x gets bigger and bigger and bigger and bigger, this term in the front will take over the function. Because a cubic grows way faster than a quadratic and way faster than these, the function basically turns into something just like this, 5x cubed. Which, whatever this is, that's the way it will grow. So when I say end behavior, we're focusing on the degree of the function. Right? It just goes bigger and bigger and bigger. The bigger x gets, the bigger the cubic function gets. Fourth degree terms are very similar, except when you take a negative value, negative x value, to a positive degree, it becomes a bigger positive x value. So your end behavior starts up and it ends up instead of starting down and ending up. Fifth degree terms are identical end behaviors as cubic, and fourth degree terms are identical end behaviors as sixth degree terms, as they are quadratic terms. This is the way it goes. Any even degree polynomial has exactly the same end behavior, right? A quadratic goes like this, up and up. That's the direction in which a quadratic grows. It starts high and ends high. Same thing with here. Any fifth degree term or even a linear term, it starts down low and ends up high. Down, then up. Now these can be flipped. The way you could change these is if you take your a value and multiply it by a negative number. Right? If you make your a value from positive to negative, everything is basically flipped upside down. If you were a cubic function, which was going like this, and you multiply that cubic function by -1, well, instead of going up and down and up, it now starts up and moves down. Up and then down. That's the end behavior of the graph. Same thing here. Any fourth degree or sixth degree function, or second degree or eighth degree or 10th degree, any even degree function, if you put a negative a value on it, it will start down and continue going down. Fifth degree and third degree, these are odd degree terms, just like your first degree linear term. Right? If you have a negative slope for a line, it looks like this. Starts high, ends low. You can make these following conclusions. I'm going to write this down. When your lead coefficient is positive and the degree is even, we call this end behavior up and up. Positive a value, degree is even, just like a quadratic, it's up and up. However, when you have positive a value, your leading coefficient, I'm going to say this right here, it's the same thing as our a value. Your lead coefficient, when you starting coefficient leading coefficient, your A value is positive and degree is odd, this is what you would call down and up. It's like a line or linear values. Next is when your leading coefficient is negative and the degree is even, this is just like quadratic, this is down and down. Lastly, leading coefficient is negative, the degree is odd. You start up and then you move down. Copy this down or move on. Also note what you can do. Let's look at this graph. I like this graph a lot. Here's a comparison between the degree of a function, whether or not it's even or odd, and the leading coefficient of that function, whether or not it's positive or negative. If the degree of a function is even and the lead coefficient is positive, that is your up and up. Right? Any second degree, fourth degree, sixth degree, eighth degree, 10th degree, any even degree function will always have this polynomial end behavior right here. Whereas this odd degree with positive lead coefficient, down and down. Moving on, if you have an odd degree term with an even degree, or sorry, if you have even, oh no, I flippy flop these. Oh geez. These were flipped. Even degree, negative lead coefficient goes down and down. Odd degree, positive lead coefficient goes down and up. Oopsies. This will become down. And lastly, odd degree, negative lead coefficient is up and then down. Down because now this one's accurate. This is the end behavior polynomials. This is huge. This is how we start to graph polynomial functions. Knowing this will help us graph polynomial functions. Move on. We're going to get adding and subtracting of polynomials. The first thing that's huge here, make sure when adding or subtracting polynomials, make sure to combine only like terms. You cannot combine terms with different terms with the same degree. That's very huge. What I mean by that is when you have a cubic term, 9x cubed, it can only be combined with other cubic terms. Notice I'm adding these two polynomials. We can just add them across like we normally do, but I can only combine cubic with other cubics, and since I don't have any other cubics, I'm stuck as is. And move on. I did my cubes. Now I'm going to do my 5x squared. Notice there's no other quadratic terms, so we're just going to add it just like that. Those cannot be combined because they're different terms. Next, my linear terms, negative 2x plus 12x, that gives me negative 2 plus 12 gives me 10x. And lastly, my constants, my 1 and my negative 4, 1 plus negative 4 gives me negative 3. Always write these in standard form, which is biggest degree first, and then sequentially lower. So after 3 goes 2, then 1, then your constant is 0. Always go 1 lower. Next is subtracting polynomials. Make sure distribute that negative sign to every single term inside those parentheses. What I mean by that, you are subtracting 3x squared, you are subtracting x, and you are subtracting negative 4. I would almost rewrite it out after you do that. We're minus 3x squared, minus x, and plus 4. We have to subtract the entire term. Now we combine like terms. This becomes negative x squared because 2x squared and negative 3x squared combined give me negative 1x squared. Sometimes I like crossing it out so I don't use it again. 3x and negative x combined, 3 plus negative 1 gives me positive 2. And then the 4 is left right there. It's written in standard form because my quadratic term, my linear term, and my constant. Biggest to smallest. Lastly, we're going to multiply. When you're multiplying polynomials, make sure, this is kind of like a bigger version of FOIL. Instead of having 4 products, we're going to have 6 products. So I'm going to multiply the x into 3 terms. And then I'm going to multiply the negative 3 into these 3 terms. And then I add them all up. When multiplying, same variable terms, make sure to add your degrees. What I mean by that is if you take x and multiply by 3x squared, the coefficient stays the same. The x variable stays the same, but x squared times x gives me x cubed. That is huge. You have to build, I'm going to write that over here because I'm going to have a lot of factors or a lot of terms. 3x cubed, x times negative 2x gives me minus 2x squared. X times negative 4 gives me minus 4x. Next term. Negative 3 times 3x squared. Make sure you're always multiplying by negative 3. Negative 9x squared. And negative 3 times negative 2x becomes positive 6x. And negative 3 times negative 4 becomes positive 12. We're not done. We're going to combine like terms. I only have one cubic term, 3x cubed. I have 2 square terms. A negative 2 and a negative 9 becomes negative 11x squared. I have 2 linear terms. Negative 4x, positive 6x becomes positive 2x, and then just the constant of 12. Thank you for watching this one. We're going to dive into more examples on our next video. Thank you.